Hey everyone, I'm David Room. I'm just going to share a quick link to this on Twitter and then we'll get started. I've got something pretty fun to work on today. So, over the past couple of months, I've been working a lot on fixing a lot of random things in the game engine. Not in the game engine, but in the in the general set of capabilities that I'm building on top of the game engine for building a space combat game. Not so much on game content. And I thought it would be really nice to get back into building some content and started sketching a few things. And I figured that it's finally time to tackle one of the space stations that I've been wanting to make for a long time, which is a space dock. So let me just show you a little bit what this looks like. Um, so first of all, here's our list of content that we need for the game. We've got some fighters, smaller ships, kind of in various stages of completion. And then I have two space stations that I've started and made some pretty good progress on. The I do have another one that is, but it's quite a bit older. It's something that I made a long time ago and it doesn't really fit currently. Actually, a couple of them. They don't really fit quite properly stylistically with the game in its current state. So that would be Station C. Would be remaking one of those. But this dry dock is a space station that's a factory for ships, and probably variations of this will appear in at least one mission, and it's something that I'm going to want to have for uh, artwork that I'll want to make as well. So not just game stuff, but the higher detail 3D modeling. And I did a little research, um, and it seems like I always called this kind of thing like a space dry dock, but I guess in general it's just called a space dock. Um, so you have something like a station. This is just from the Wikipedia page where you have robotic arms and stuff that can operate on it, work on it. Um, some other nice artwork like for the Star Trek stuff. So I'll show you what I my concept art looks like. Um, so I've made little sketches of this kind of thing in the past, but it's something like this. So I imagine sort of a kind of a scaffolding like structure. You have this backbone that would kind of run along the length of it, and then at intervals you'd have these arms that come out, and then kind of in between there is where the ship would be built. And this is going to be an interesting one to build because I think a lot of it's going to be building different components that can be remixed and reused. You could imagine dry docks or space docks that are different sizes. Some little ones that might work on some smaller ships with shorter arms, and bigger ones that could work on big ships with longer arms, or a lot of them, or things sort of built in different directions or layered on top of each other. But I something I want to do with this is I want to get enough detail in there that it's interesting to look at, and there's parts that sort of make sense, and yeah. So let's dive in. For starters, I'll just bring up a couple of the space stations that I've built already to show kind of what my process looks like here. If any, for anybody who might be new, watched who hasn't watched my videos before. So I'm actually making all of these models using Python, using kind of a custom set of tools that I've built myself, and I'll show you what that looks like. So let me close everything here and open my bench. I usually have a bench script that I use to generate something and then preview it in Blender. So we'll just start at the top. It is truly a workbench where there's extra bits of leftover projects and everything. So let's see what I have. Yeah, and I've got a bunch of stuff imported here. So I'm forgetting now, it's been a while since I made the second space station. So project spacecraft, import station B, and we usually have parts and data. Station B, and these functions that produce the model always take a single argument, which is the level of detail. And I forget. Okay, so this usually it returns a set of parts and a data dictionary. The set of parts is a dictionary where the keys are names and the values are each a part, which is a object that has a transformation, it has a parent, which is specified by name, and it can be a model or different things. And then that is the format that I export and load into the game. I can export to Blender. It's my own simple format for a hierarchy of 3D models. So if we look at this guy with, we can look at the set of parts like this, and we can also view it in Blender. Like this. So if we run this script, our bench script, so it's running some code that generates station B, and I worked on a bunch of this on stream, adding some specific details, specifically these like alignment thruster things. So there's kind of what it looks like in this Python viewer, and then if we close this, it's going to open up Blender, which actually opens very fast, and it's a little bit too big for Blender without scaling it. It's clipping, so we should have scaled it down first, but we can also view it and interact with it in Blender. And this is basically a one-to-one arrangement of how it's structured in that parts dictionary. And things work a little bit differently once we load it into the game. It doesn't necessarily follow the same hierarchy. Certain things get flattened out. But that parts hierarchy is our starting point. So let's jump right in and make a new script for our doc. And I'll just call this, doc. Okay, so in projects, spacecraft, space station isn't necessarily a spacecraft. That's just how this is working right now. So we've got our doc, and let's just, for starters, to save time on importing everything that we need to import, we will import everything from station B, and then delete what we end up not using. It's way faster to import a bunch of extra stuff than to be constantly stopping to import things and move them around. So we'll pop this in here, and this won't be a script that will run, so we can get rid of the main stuff. So now we'll make the entry point doc with the LOD, and this will be a tuple of parts dict and dict data dict, which is just string any. So the data in the data dict can be used by the game loader and different things. It's basically just a dictionary that gets pickled, and everything is all the keys are just strings. Okay, so let me split this and just load this up so we're ready to start looking at it. And sorry, just one second here. Sorry guys, I just have to send a quick email here. I'll start streaming back up in just a second. All right, sorry about that. All right, so if we look at station B, the way these, I usually have one module for each kind of big, like individual thing, and sometimes I reuse parts, but I have a lot of constants that describe the attributes of the thing that I'm trying to build, so I don't have to dig around in different subroutines to change the dimensions of things. So let's just start by blocking things out with like rectangular box meshes. I want to see if I can kind of get going with something that we can start looking at and interacting with quicker. So I'm going to call the back of the thing the spine. So we'll call the cross section of the spine the rib dimensions, and this should be pretty big. It should be something like 10 meters by 20 meters, and the spine length should be quite long, like 200 or 300 meters. Let's go 300. And then we'll call the individual sort of things that come out, these things that stick out, we'll call those piers. I think that's what I called the parts for Shima Station. Yeah, piers. So we have and we'll just call this XD instead of dim. Rib. Okay, so the pure ribs are gonna be about the same because what my intention is the spine is gonna be like multiple of these stacked so that the ribs can kind of slide back and forth between them. So we'll start it. Actually, we'll just make this square for now. And we'll do 20 meters. That's quite big. So make this 20 by 20, and this will be something like 150, because that would fit up to, like, you know, Corvettes or things. And eventually we can parameterize the parts of this and swap in different values for these ribs if we want to build different things. But we'll just kind of start by making a particular thing, and then we'll parameterize it. I think that's that's in general a really good practice, is like not to over abstract things too much at the beginning. Okay, so the next thing will be just trying to think if there's, yeah, I want to just get this going. So we'll call each part, we'll call it a truss. So so we'll just make a truss that's 3D.box mesh, and I always make things long in the Y direction. So we'll do pure XC, whoops, C0, 1, like this, and then so that'll be our spine truss, and then we'll do pure truss as a box mesh using these dimensions. Okay, and let's just quick try to put this together. So we are going to have our results be so we'll just have a root as a part that is just an empty. Actually, we'll call this the spine, and then we'll have the spine A be one truss that's like offset vertically, and then the truss B be offset vertically in the opposite direction. So here our parent is going to be spine model equals spine truss transformation equals ps dot translation of and we'll offset in the z direction by half of the spine truss size, actually half of the pier truss size, because we want the pier to fit in. So pier rib xz 0 divided by 2. Okay. And just see what this looks like. So we're just expecting 2 long rectangular things. Doc. We need to return stuff. We need to return. Okay. Yep. Okay. So yeah, we need to add. So that's just takes care of. Actually, we'll just make a spine truss offset. Z is the spine 0 divided by 2 plus the pier rib x z. And that should be 1, 2, and then we can use this in both spots. Okay. Whoops. Other way. VZ just makes a z vector of that length. So okay, there we go. All right, so for that length, 20 by 20 is actually pretty big for the rib size. So let's actually knock that down to 10 by 10. Actually, maybe we can make this a little bit. 400 is pretty big. Let's still go 350. We'll knock this down to 10 by 10 as well. Okay, now let's add some piers. So all right, cool. Sorry guys, I'm trying to schedule something here. Okay, cool. I've got time. Okay. All right, so let's make some piers. So the piers are going to be rotated and then offset. So right away, I think I'm going to make a little function here to make a pier part that's at a certain offset along the spine. And just so we're not repeating ourselves here. So the parent's going to be the spine, and then the model's going to be the pier truss. And then our transformation is going to be a little bit more complicated now. So it's going to have a rotation, which is going to be rotated 90 degrees in Z to make it perpendicular, right? And then our translation is going to be, so the length of the pier is, so when we rotate, we're going to be aligning it in the x direction, right? So we need to translate it back for half of the pier length, And then there's going to be some other little offsets here. But this will get the general idea. Then y will be our offset that we're passing in. And then z will be 0 because it'll be right in the middle. It's kind of nice when you're building these things to start thinking about, you know, the coordinate systems that the pieces are going to fall in. And I think it's nice to have these piers be at z equals 0. So now we can make a bunch of piers just with a ticked comprehension. So we can do key pier part offset for key offset in, actually we can make the key ourselves. We can just do pier index, we'll just call this off so it doesn't complain at us. So how do we want these to be spaced? I'm picturing, we'll start out, we have they're 150 long, and I'm thinking they should be like 30 meters or maybe 40 meters apart would be a nice amount. So we can just manually enumerate the ones that we want. So we want something like minus, we'll do minus 100, minus 60, minus 20, 20, 60, 100. Does that make sense? Are those all 40 meters apart? And we have, yeah. Let's just see what this looks like. And we can pop that in here. Yeah. Okay. So this is okay, so I've got a chat here. Can you explain what I'm building? So I'm building a 3D model of a space dock for my space combat game. And I'm using Python to do it. So I have a little sketch that I made here of, you can see this kind of scaffolding with different structures and these kind of piers that a spacecraft, like a big ship, would go in between with robot arms and stuff that could work on it. So I'm just sketching out the sort of basic shape of this dry dock. And maybe what we'll try to do here too is we'll try to get some ships into it when we start looking at it in Blender for scale, so we can see if we're on the right track. Hope that answers your question. Okay, so yeah, this is looking pretty good. And I could actually, if I do a couple more, so if I did minus 140 and 140, and then let's see, so that's 140, it's like 280, I think. So we could do 300, and we can parameterize this stuff more, but something like this, yeah. Okay, now let's actually, I think it would be a good idea to try to get, let's see, what do I want to do next? I'm gonna actually, I want to attach a couple of structures to the back of this just for scale. So yeah, because I want to start getting an idea of the scale of those and how they fit. So let me actually just start bringing some of this into some different functions. So peers, LOD, actually, we'll do one for the spine too. Okay. We're gonna do, we'll give this a root parent here. And just make sure that this still works. Oh, it does not. Probably just forgot to return these. Yeah. Okay, there we go. Now, yeah, let's build a little, let's build a sort of a structure on the back. I'm getting some ideas about how I want to extend this as I'm building it, so that's good. So what do we want to call this this house type structure? It's like the it's like maybe not like the tower, or I could just call it the, I don't want to call it station because that's like this like space station. We'll just call it the house for now. So and for now I'm just gonna, it's just gonna be a simple box. So this will be something like this will be something like 40 by 40 by 60, or 60 by 40 by 60. And then I'm also gonna grab so Um, and for now, it can be right at the middle, right in the middle, but we need to translate it back. So we need to translate it back. We need to translate it back by half of its x dimension and also half of the spine rib x dimension. And I'm going to bring in a couple of other things too. So there is I have a bunch of cargo container models, and in a set of parts, let's see here, containers, and those are going to be nice for establishing scale. So we have like the beveled cube, we have lobed. The standard shipping container is kind of nice because that's a nice size reference. The prism, yeah, and then I've got a very large capsule. So I'm gonna bring in a couple of these capsules. So so let's see here. So we'll call them capsule three. And this is going to be a part where the model is containers, capsules, containers, container E, passing the wad. Model is capsule and transformation equals transform. Okay, so the capsules are going to be coming in aligned with the y-axis, but we want to flip them up, so we want to rotate them around x by 90 degrees, and then the translation will translate them off from a center point, which will be in capsule 0. So we're going to do, and they'll also translate along x. Actually we'll call respective parent called capsules. So yeah, so they'll translate on either side. So we'll want to do where am I missing? There we go. Okay, so index -1. Oh, nice. Yeah. So, Musam, are you a Python programmer? Do you have experience with Python? so I program it in programming in Python here, not doing anything super fancy, but it is a little bit of a functional style. So we're going to multiply this now by the size of the container radius, and we actually need to go. Okay, yes, he's learning. You're learning Django. Nice. Yeah, I have like almost no experience with uh like a web stuff. So I've done a little bit with Flask and a little bit with some libraries for building little web apps for like machine learning stuff, but I don't have any experience with like a big like more rigorous web framework like you would use, except for a very long time ago I did some stuff in Java, but I haven't done anything like that in Python. So we want to offset it by twice the radius because that's the diameter. So like if we have a container at 0, then the midpoint of the next container when we translate it over is going to be is actually going to be, yeah, it's going to be at the diameter. Offset, okay, and then we'll add a capsules equals just a part, and parent equals house, and we will do containers. And let's see, I want to stick the, just for now, we're going to stick these containers on the side of the house, so we're going to want to shift them forward. We're going to want to shift them forward by the Y size of the house. So transformation, translation. So the X offset will be the house dim. We'll stick them in the center. 2. And the stem, divided by 2. So that I think should put them roughly where we want. And let's see. Usually it takes me a couple tries to get stuff in just the right place. Okay, what am I missing here? Oh, this should just be X. And this should be also just a VX. Okay, cool. Yeah, okay. This is almost what I expected, except yeah, we didn't shift this in the right direction. So the house needs to be translated. Just a second. What is going on here? Oh, interesting. So these, we actually want the piers to go out the other direction, because I want the piers to go out the positive side. Then the house can go out the okay. Yeah. I want the prefers to go out the positive side. Then the house can go out the negative side. Now I just got to figure out the correct offset for those containers. So they should be going negative. So we want to do negative this, negative this, but then we also have to add in the container radius again. So containers dot e radius. Oh, I know, that's why it's giving me grief. This is I'm shadowing the name here. So, okay, so Musam, he says, any advice for becoming a Python developer? And do you have any ideas about growth opportunities in Python? These are really good questions. I think, so in my professional life, I work in machine learning research and scientific computing and things like that. So that's kind of how I got into Python, is through machine learning stuff and adjacent kinds of work, image processing. So in research, you're trying to build code quickly and test it. And there's a lot of nice wrappers for things that are written in other languages in Python. So that's how I got into it. I think, though, my advice to anyone who's trying to get into programming and learn anything is come up with a project that you're excited by, and then use that as a way to practice and grow. So if you can find something that an area that overlaps with whatever you're trying to do professionally, even if it's just a little bit, and then go after that as like a side project. And if it's something that you're personally excited about, then that will give you the motivation to learn it. You're not just going to be learning the language for its own sake, but you're going to be, there we go, almost there now. Oh yeah, and I don't actually need this offset, right? Because it's already going to be centered. So it's just that one. Yeah, look at that. So I want to just make this house a little bit bigger so that it can fit those containers. Capsules. Oh, this image. Yeah, if you can find something that you're excited about, then that will motivate you to. Man, I'm just having a tough time here. That will motivate you to learn. So like if you're interested in Django, can you build an interesting web app that does something that maybe might be useful to you in your own life, or something for a friend or relative or a project. And then when you start building it, you'll run into things that you don't know how to do, and you'll be like, I wish I could get this working, and then that will give you the motivation to figure it out. And learn. So that would be my advice. And doing is worth a lot more than reading or watching videos or anything. Doing is where you're gonna find out what you don't know, and that's where you are going to learn. And then once you have those things, then you can take them to guide your research and reading and whatever. but it's important to be trying to do something, I think. Let's see here. Yeah. And actually, I want this to be like this. Something like this. Yeah. So the way I was imagining it is that this structure could kind of like move back and forth along this spine. So like the people who are supervising, like maybe they have some nice windows here where they can look out on the dock of a particular ship that's being constructed. Or if there are, you know, parts or different things, they can be hauled back and forth. Okay, so this is looking really good for kind of a rough block out. What I'm gonna spend the rest of the time doing here is I'm gonna try to get a couple of ships from my set of ships into this, and we'll look at it in Blender and then make some final tweaks, and then we'll be done because I have some other things to do this afternoon. But I'll probably come back to this soon. It's the trickiest part of these kinds of things is always just getting started. And then once they're started, you can make lots of little tweaks and refactor, and you have something to start working with. So first of all here, I don't like this. So instead of having this hard coded, we're gonna do something like this. So we'll call the space between piers a stall, and we'll call the stall width, we'll call that space the width. So the stall width here is 40, and there are 1, 2, 3, 4, 5, 6, 7 stalls, right? So that means that instead of doing this, we can enumerate a range, and let's just use numpy.arange because I think actually pi.linspace is the best for this. Yeah, because we know we want to go to so total width is stall width times stall count. So we want to go from in our so we want to go from start is total width negative total width divided by 2. Whoops. And stop is total width divided by 2. And num is going to be, I think, length of stall count. Oops, not length, just stall count plus 1, because we have one more pier than stalls, and then endpoint is true. I always forget exactly what the right combination of parameters is to get this in NumPy, but we can take a look. It should be pretty obvious, especially if we load things into Blender, if we got it right. Nope, that's not right at all. So, oh yeah, there we go, stall count. Yeah, that's just what we want, because we have 1, 2, 3, 4, 5, 6, 7, and we can write a little function. So given the stall number, like what is the center point? We can use this to put ships in. So stall center is going to be, and this will be a vec3. If people are curious, these types that I'm using, they're just aliases, simple aliases for NumPy types that are of certain sizes, and I have constructors that just build NumPy arrays. So there's nothing that enforces these things to be exactly the size or stay that size, but it just makes it a little easier to work with things, to have these kind of custom types defined. So okay, so we know that again, kind of know our total width is going to be here. So the center is going to be negative total width divided by 2 plus stall width divided by 2 plus stall count times index. That should be correct. Okay. And then that is just the y, the y dimension. So the x dimension is going to be half of the pier length. And we don't have any additional offsets right now, so, and this will be fine approximation. So now we can return a vector like this, and we can put some ships in our dock. So here will be our dock. Now let's build a ship. Let's build the Scioto. It's one of my favorite ships that I've built. So we'll build the Scioto, and we'll add a prefix to this. So we'll add dot add prefix Scioto. Yeah. Okay, so we'll add a prefix, and then we'll find the root, because there's going to be a single root of this, and we'll set its translation to be in the second dock. So grab this root, and we will make its parent so just equal the root of the dock, and then we'll put these guys together. So we can concatenate, because each set of parts is like a dictionary. We can just concatenate them together. We can concatenate them using normal built-in Python dictionary concatenation like this. Like this, right? That's valid, but I have just a little function that kind of makes it clear what we're doing, where we can concatenate like this, and this function just looks like this, where concat is just repeatedly applying that. Okay, so now we can take a look at this again, and then if this looks good, then we'll look at it in Blender. See how we did. Whoops. Oh, and gotta toss the data off of that. And there we go. Interesting. So, okay, yeah, it's probably the equal, so it doesn't have a transformation defined on it already, which makes sense. So, we'll just add that. Oh, that's too bad. Let's see here. Oh, yeah, and that's not it. That's not the right function at all. So it is stall center. There we go. Okay, cool. And we just also need to add a little, we need to add a twist to it. So we want to add a transformation where we do a rotation is a mu dot negative, is it 90-degree rotation or negative 90? I guess we'll see. It's easier to test things sometimes. Oh, do negative 90. All right, okay, so 40 is a little tight, even for a smaller Corvette. So we're gonna expand that spacing. This is the great thing about doing this with code, right? So let's just say, oh yeah, instead of 7, we want 5, and we'll do 60 meters for the spacing. Yeah, look at that. And we can make our spine a little bit longer, like we had it originally. Cool. I'm just gonna add one more ship, and then we'll take a look at it in Blender, and then we'll go from there. Okay, so so we'll just make this a loop. So for ship name in, actually we'll do the name first. So that's 0, and we'll do a big scary ship too. Go. Okay. And name, and we'll do the stall index here. So we'll do stall 1 and stall 2. Oh, I know what's going on here. that's weird. So there's that ship, but it is not over in the right stall. So maybe I got my stall center function isn't quite working like right. So we want negative total width times 2 plus stall. There we go. There's plus stall width 2 plus. Yeah, so this isn't stall count. It is index times stall width. Yeah, look at that. Okay, cool. So, couple of ships sitting in there. Let's take a look at it in Blender and see if we notice anything off about it. Maybe do a couple final tweaks and then we'll be done. Okay, so Tigerbolt has a good question. Are you just using Python as a 3D editor for fun, or is there a specific need that Blender couldn't fill? Well, that's a really good question. So part of it is it is fun. So I'm a programmer by trade, and I like programming and I like doing things with code. You could certainly do all of this stuff in Blender, and it probably would be faster. What isn't faster though is, you know, when you start parameterizing things, like I just did, where, you know, you've got this design that you want. Like I know I want this dock to have like a spine and these piers, right? But I don't know exactly how many of them there should be and how wide they should be. Well, that's just some variables in code that I can change, and I can regenerate it and instantly have an updated version. Now, of course, you could do that kind of programmatic stuff in Blender with something like geometry nodes. I actually started building this software before geometry nodes were really a thing in Blender. Also, I think what kind of bothers me about geometry nodes is that it's like the visual programming where you're dragging things, and I'd rather just write code. And when I write things in Python also, I can export, and I can export them to these different formats. Like there's no round trip through Blender to get back to the format for my game, for instance. So I can export the same structure to Blender, or I can export it to the format that's required for, and load it in the format that's required for Panda 3D, which is the Python game engine that I'm using. So those are a few of the reasons that I'm using Python. And something you could do too is you could run, you could like build the code to do this inside of Blender and run it inside Blender's internal Python. But for my workflow, I'm running stuff outside, so it's not like I'm not stuck in Blender land. I have some flexibility. Does that answer your question? I hope that answers your question. It's a really good one. Okay, so this is looking really good. I think what I'm going to try to do here, just with the last little bit, is I'm going to try to replace these piers with actual trusses, and then we'll be done. So first of all, here, let me just comment out the Blender viewing, and we'll comment out this first thing. Yeah. You have a good evening to Tigerbolt. Okay. So we'll do, I'm gonna knock these in half again. 5 by 5. And I think what I'm going to end up doing is I'm going to end up making that spine be like four of these trusses, rather than 2 stacked on top of each other. It'll be like a square of 4 of them. Okay, and then let's see if we can actually replace it with a actual truss rather than a box mesh. So, and again, this is kind of the fun thing about programming, is like you can sketch these things out, you can get the dimensions right, and then hopefully you can replace things with higher detail pieces. And okay, so spacecraft shared dot truss, and we're gonna do truss low. So what do we have here for arguments? We have length, a radius, number of chords, chord thickness, segments, ends. Okay, so our length is still going to be our pier length. Radius is a little bit tricky because what we want, so we originally had a box that has a certain width and height. This is going to actually generate a truss that could have like a certain number of sides, and we don't want to use a nice even radius. Like the radius is not just going to be pier rib XZ. We want to scale that. So like if the radius that we want is basically half of the length of the side times the square root of 2, I believe. So our radius is going to be pier rib XZ, and this is assuming that it's square, which is an okay assumption here, times math dot square root of 2. There's going to be 4 chords. Chord thickness is going to be try this. If this looks good, then we can take these settings back to the spine. Segments, so we have nice even amounts for the pier truss length, so we should be able to go pier length and say like just divided by 2. And ends, we do want ends, and the web thickness is going to be like half the chord thickness. Or actually, it could be just the same as the chord thickness for now. And I think that's it. Now, this is going to be rotated. We need to rotate this by 45 degrees to get it to line up right. And let's just take a look at this to make sure that it is what we are expecting. Before and after we rotate it, we're almost done here. Almost done here, and we made some really nice progress on this. So here's truss. Actually, this is mesh dot rotate mesh. Here's truss, and the rotation matrix is going to be going to rotate it around the y-axis by 45 degrees. I like to describe rotations in terms of tau, which is pi times 2. That's the number of radians in a full revolution. So, pier truss, pier truss, pier truss. Okay, let's see what this does, if I did it right. Okay, looks promising. And whoop. Come on, mu dot ry. There we go. Yeah, okay. So this looks just right. And this has a lot of faces, but we can easily cut down on this. I think, yeah, pure length is 150. We can make this some nice multiple of nice even number in terms of like a power of 2 or a multiple of 2. So we could do like we could do like 4 times let's see, like 4 times 48 32 4 times 40 is 160, and then we can do divided by 4. Here it is. Truss. 4. That cuts the number of faces right in half. Looks pretty cool. Let's do the same thing with the spine, and then we'll be done. Okay, so let's see here. And this is spine rib, XZ, truss. Later I'll pull this out into a function. And we'll do a nice multiple of 4 for the spine length as well. So yeah, we could do 90 times 4, 360. Yeah, look at that. Actually, let's see here. Because we want, what do we want? I want the segments to be the same across both. So here, each one has 40 times 4. So the segments is 40. Yeah. So here actually I can't think. I need to take a break. We're gonna just hard code that to be 90. Yep, and then things match up. Cool. All right, let's take a look at it in Blender one last time, and then we'll be done. Good progress. Yep. Cool. And you know, our total number of triangles here is not insane. So like each one of these, yeah, I guess. Yeah, each one of these has like 1,000 triangles, 2,000 triangles. So total, we've got like 16,000 triangles. I don't think that's really too big of a deal. I have this kind of low poly look in mind for the game, but there's times when I'm kind of willing to violate that. We can also do some LOD stuff where we can do some lower detail stuff at a distance. But this is looking like a pretty good start. Can slap some smooth shading on those capsules too. Let me just do that quick. So we can add smooth shading with the property. So yeah, auto smooth angle. It's like 30 should do it just fine. Yeah. Needs a little bit more than 30 actually. Cool. All right. Well, I'm gonna leave it at this, but I think we got a good start. Definitely, you know, a lot more detail will be added here. I want to do some cool stuff with you know, like robot arms, other parts. I want to try to sketch out something that looks like a reasonable mechanism for how these piers might translate along this on rails. Have rails for robot arms, alignment thrusters, antennas, a reactor for the house or station, like dock house part of this, stuff like that. But this is like a good start as far as some of the key like design of it. I think I probably will do something where I do like 3 or 4 of these, and then there can be like a set of rails, or there could be smaller piers on the back. I'm imagining something like rails running across the front of these, and of course there needs to be like more bracing and stuff, but to hold things together. But rails, and then like wheels, the suggestion of wheels that these piers could like translate along. So we got a pretty good start here. Thanks everybody for watching, and I hope this was interesting, and for sure, like, check out some of the other videos on my channel for a look at what the game looks like, kind of the style that I have, where this is going. I have a lot of other videos of me doing programmatic 3D modeling, if that's something that you're interested in. So